and welcome to my channel. Today we are going to be taking a look at the brand new Nios V softcore processor. Now this processor has been available on the Pro edition of Quartus Prime for a bit, but has just recently been released for the standard edition. And with being released for the standard edition, we now have it available for our Cyclone 5 family chips that we use on our DE1 SoC and our DE10 standard boards. So today we'll be playing with our DE1 SoC, and we'll implement a really simple Hello Nios V processor, and we'll implement a Hello World application on that processor. But as always, first, if you like my videos, please like and subscribe to the channel and like the video. It does help out. And let's get started. Okay, here we go. We have our Quartus window up, and we're going to go ahead and do a new project wizard. We can go ahead and hit next here. Let's throw this into our Git repository so everybody can have access to it later. YouTube channel, we'll put it under D1 SoC since that's the board we're going to play with. And then I'm going to do a new folder, and we'll call this Nios V Hello World. And we'll go ahead and select that folder, and the project we'll just call Nios V. Keep it short and simple. We're going to do an empty project, no files to add at this point. We are using the DE1 SoC, and we can go ahead and finish up our creation of our project here. Alright, our project's created, and if we go to that folder, we can see we have our database and then our Nios V, QPF, and the QSF files created for us. So, like always, when we're dealing with a softcore processor, the first thing we're going to do is fire up Platform Designer, and again, there's two ways we can do that. The first way is we can hit the button on the toolbar right here for Platform Designer, or we can go up to Tools and fire up Platform Designer from here as well. Either way works. Either way will execute the tool. Okay, we have Platform Designer up. Let me drag it over into this monitor. And like before, we have our clock in here, and we're just going to do something really simple. We're going to add a Nios V processor. So we'll double click on that. And for now, we're just going to go ahead and hit finish. We want to take the defaults. We're going to need some on-chip memory. So we'll go ahead and add that component. Now we're going to need more than 4K, so I'm going to take us up to 128K. So we'll change this number to 131072. That'll give us 128K of SRAM. And the last thing we need is, of course, a JTAG UART. So we will add that component, and I'm just going to take the defaults there. Just like we always do, I'm going to rename these. So I'm going to name our JTAG UART debug. We'll name our memory SRAM. Let's name this my Nios V. And a couple more things we need to do. We need to set our reset vector. So I'm going to set that. Oops, I haven't added everything yet. I'm going to go ahead and do this part first. We're going to enable reset from the debug module and make sure we've got debug enabled. Now let's go ahead and wire this up, then we can fix everything else. So we need clock going to the processor. We need clock going to the RAM. Hello, come on. And we need clock going to our JTAG UART, of course. We also need reset going to our processor. And we need reset to our NDM reset module that we just enabled. And then we need reset going to the RAM, and we need reset going to the JTAG UART. But we also want to be able to reset everything from JTAG. So debug reset out is going to wire up to that reset in. The SRAM needs both our instruction and our data managers. The JTAG UART just needs the data. We're not going to be doing instructions from that. And of course, we need to wire up the IRQ. So that should do the basics. Let's go ahead and do a system, assign base addresses. That should get rid of most of our warnings and errors. We do need to come in here and set our reset vector to go to the SRAM. And then we can go ahead and save this project. And I'm just going to call it Nios V. Same name we named our top level of our design. And we will wait for this to save really quick. All right, we're all green. The save is complete. Now we can go ahead and generate our HDL. And for this demo, I'm just going to take the default. So I'm just going to go ahead and hit generate here. All right, our HDL generation is now complete. I can go ahead and close that, and I can hit finish in our platform designer. And like always, it's going to come and tell me that, hey, you create a new IP, you should probably import it. So let's go ahead and do that. We'll go over here to files, and we will add in our file. We'll hit the little three dots. And we're going to go into that Nios V synthesis folder, and we want the nios5.quip file. So we'll go ahead and bring that in. And hit OK. Let's go back to our hierarchical view, and we'll go ahead and we'll do a quick compile as start analysis and elaboration. This will allow us to assign the pins that we need to assign. And in this case, the pin we need to assign is just the clock. All right, we have our quick analysis and synthesis compilation done. So with that, we can go into the pin planner. And we can go ahead and assign our one pin, which is just the clock. I'm going to set that to location AF14 because that's where I know the 50 megahertz clock is for our D1 SoC. And I'm also going to change our voltage to 3.3 volt standard. We'll go ahead and do that, and we will go ahead and start that full compilation process. And while that full compilation process is started, we can go ahead and get started on our software side of this thing. So the first thing we're going to need is a Nios V shell. So I will go ahead and open up one of those. So here we got our Nios V shell here. And I'm going to go ahead and change to the D drive. Let's go to our D1 SoC and our Nios V Hello World. So here we are in our project folder. I'm going to go ahead and make a directory called software because that's where I want to throw all of my software. Now, unlike the Nios II, the tools aren't quite as integrated, so we're going to have to do some things from the command line in order to get our software started. And the first thing we need to do is actually create our board support package so we can do the software. And we do that by running a utility called Nios V-BSP. Now, if we look at the help of this command, it will show us the various things that we can do, as well as some examples. So let's go ahead and create ourselves a board support package. So we're going to say Nios V-BSP. We want to create a board support package. The type of package we want is a hardware abstraction, Altera hardware abstraction layer package. Our SOPC info file is our name of our project, nios5.sopcinfo, and we can verify that by looking in our File Explorer, and there we see our nios5.sopcinfo. So that's the name of our SOPC info file. And then we just need to give it where we want to put this. So I'm going to put it in the software folder, and I'm going to put it under a directory called BSP, and we're going to call it settings.bsp. And then I'm just going to go ahead and hit enter here, and we will create our board support package. Okay, our board support package is now generated. If we go back and we look under our software folder, we now have a BSP folder, and in that BSP folder we have a lot of things that were created for us, including our settings.bsp. While we're here, I'm going to go ahead and create a new folder. I'm going to call it app, and then under app I'm going to create a new file, text document, and we're just going to call this hello.c. I need basically a blank file so I can create the application that we're going to use here in a minute. So now we've got that created. We can go back to our command line, and the way we create an application that we're going to use is with another command called Nios V-app. And we can do the -- help thing again, but basically we're just going to use this command. We're going to say -a, and we're going to say the app name is software/app. I called it something simple. All right, so we're going to put that in software app. Next thing we need to do is specify our board support package. Well, that's in software/BSB. BSP, not B. And then I need to specify my source files. So that's software/app/hello.c, which we just created. So I'm going to go ahead and hit enter on this, and this should create our application. So our software app was generated. So there we go. All right. We can kind of minimize this now, and next thing we need to do is fire up the Risc-V IDE. So I will go ahead and do that. Risc-V IDE is kind of based on Eclipse. So we got to give it a workspace. So I'm going to go ahead and hit browse here, and we're going to go to our D drive, Nextcloud, YouTube channel, D1SOC, Nios Hello World. And we're going to go to our software folder. That's going to be my working directory. And then I'm going to go ahead and hit launch here. Okay, now we're here. We need to create a project. So I'm going to go ahead and hit that create a project, and I want to create a general project. No, I want to create a C project. I want to make sure I select CMake driven and empty project. I'm going to put that project in our app folder, and I'm going to name it app, same name that I created it from before. So when I created that application from the command line, it created a CMake file, and this is just pointing the Risc-V IDE to that CMake build file. I'm going to go ahead and hit next here. These are all fine, and we can go ahead and hit finish. It's going to give me a couple warnings, which is fine. Here we go. There's our hello.c. We can go ahead and write our hello world. So I want to do a pound include standard io.h. Let's do an int main void open curlies, and let's do a printf hello Nios V world with a /n, and let's return a 0. Just a very simple program. Go ahead and hit save on that, and then I'm going to right click on the application, and I'm going to say build project. This will compile the CMake file and then build the application that's built from the CMake file. All right, as we look under our build debug, we'll see there's our board support package, our make files that were created. Everything looks good. Let's go ahead and minimize the Risc-V IDE here for a minute. Let's go check on our Quartus build. Looks like we're still building in Quartus. So we will pause the video here for a few. All right, our compile is complete. We can go ahead and program our DE1 SoC. So I'll fire up the programmer here. And we'll hit our auto detect. And we want to choose the 5 CSE MA5, that's the FPGA. Change our soft file. Output file is nios5.soft. And let's go ahead and save our programming file really quick. And we can see that my board is currently in its default unprogrammed state. I'll go ahead and hit start here. And we can see we are now programmed, nothing's happening. Go ahead and minimize both of those. And let's bring back up the Risc-V, and I'm also going to bring back up my Nios shell. I'll put them side by side. So, in order to see the output from the JTAG UART, we have to run another program in our Nios V command shell called juart-terminal. So we'll go ahead and run that. You can see it started up, and now we're ready to run our Hello World application. So I'm going to go back over here to the Risc-V IDE. I'm going to right click on my application. I'm going to say run as, and then I'm going to choose Ashling Risc-V Auto Detect Hardware Debugging. And the first time I'm going to run this, it's going to ask me some questions. So I want to run app.elf. That's my Risc-V build that I want. And then it should come up and prompt me for some hardware setup. So first thing we need to do is go to the debugger tab. You can see it's already set for the JTAG port that we need. We can click the auto detect scan chain. It's going to default to the HPS, the hard processor system. In that Cyclone 5, we want to hit the drop down and choose the 5 CSE, which is the FPGA, and when I choose that, it automatically finds the Nios V softcore that I've put in there. I'm going to go ahead and hit apply and run. And that will download our application, as we see here, and then it should launch said application, and there is our Hello Nios V world. If I wanted to run this again, I would have to hit the terminate button here to stop the processor, and then I can just say run as, and I have to choose my ELF file again, but this time it won't ask me to set up the hardware. It should just run on said hardware and give me a second Hello Nios V world. So that is a really simple introduction to the Nios V softcore processor. The Nios V processor is based on the Risc-V architecture. So it's kind of an update to the Nios processors that we've had, first one in quite a while. I saw today that for the pro versions of the tools, they just released another new version of the Nios V, so we'll probably have to wait a bit before that one rolls out to the standard edition. Right now we've just got a base Nios V processor that we can use. Like always, check out some of my other videos, and again, like and subscribe if you like the video, and subscribe to the channel if you like what I do. Have a good day, and I will see everybody in the next video.